Hello, my name is Andrew Morris. I'm a retired electronics engineer, and my gadget this time is a dimmable LED desk lamp. I recently discovered how cheap these high brightness white LEDs have become and wanted to make a dimmable desk lamp. I designed a electronic LED control circuit that's simple and energy efficient, and installed it in a fluorescent lamp that I had bought at a flea market years ago. At full power, it uses about 5 watts of power. It's dimmable from what I call a nightlight level to a retina burner level. But seriously, do not look directly into the LEDs at full brightness because it might damage your vision. There's very little here to demonstrate, but this project is not really about the lamp itself, because your lamp is going to be totally different. It's really about the circuit that controls the LEDs. The LEDs are wired in series strings like Christmas tree lights. I recommend a maximum of 36 LEDs per string in order to have good power supply headroom, but you can parallel the strings to get to power a large array of LEDs. This lamp has 2 strings in it for a total of 32 LEDs. The one LED here you can see is being used as a voltage reference for the current regulator, and it goes all the way, it goes completely out when you turn it all the way down. If you don't like that, you would have to replace that LED and its complement in the other string with Zener diodes, which would use the same amount of power but would not produce any light. The only real penalty you pay for the circuit's simplicity is that the circuit is not isolated from the power line. That means that all the components have to be enclosed or insulated in some way to prevent electric shock. But if you do that, the circuit is as safe as any other lamp or appliance in your house. What I have here is a breadboard of the same basic circuit used in the lamp, except this version forces the secondary string of LEDs to track the primary string. This is a situation where if you have to have more than 126 volts worth of LEDs, but you can't match the strings. Like in this lamp, the 2 strings are matched, but if they're not matched, then you have to add a transistor to force the 2 to track each other, and that's about it. Now I can unhook it. If I unhook the secondary string, you can see, and you see the primary string gets a little brighter when I do that, because of the ripple on the capacitor C1 goes down, causing the average voltage to go up, because the circuit regulates the peak voltage. I would not dare touch a circuit like a hot circuit like this without an isolation transformer, because I might get the snot knocked out of me. But seriously, if you do not work on a circuit like this, if you're not very familiar with line-powered circuits and their safety issues, first of all, you need a switch so you can turn it off if something happens, and you need an isolation transformer. Besides the safety issue, if you hook an oscilloscope up to this circuit without an isolation transformer, you'll see fireworks. So because of that, I strongly advise you to buy an isolation transformer. Allied Electronics sells one similar to this for about $21, and I included it in the parts list for your convenience. Thank you very much for your interest.